Hey everybody, welcome to chapter 13, digital forensics. This chapter we're going to talk about uh, actually kind of what the core is of law enforcement forensics, which is the analysis of data that's found on devices that are captured in the field. So we're going to talk about explain the process, suggest probable locations for particular types of evidence, explain how the storage system works in the computer, describe in broad detail how information is stored on hard drives, identify and explain hidden sources of information on the hard drive, identify common storage media, outline a basic universal procedure, and explain the basic logical structures of the hard drive. First of all, this is not going to be an extensive digital forensics course. When you leave this chapter, you're not going to go to court and testify um, on your forensic prowess. Um, this is meant as an overview or an introduction to digital forensics, give you an idea what digital forensics is, how it is applied, and give you a good understanding of what it is, law enforcement forensics, or law enforcement digital forensics and civilian digital forensics try to achieve. All right, so technical knowledge is secondary to the forensic analyst's ability to present technical information in court. And the reason they say that is you can be a great technician, but you may be lousy as a teacher. And that happens quite a bit when you have people that are very, very good at a science or something like that. They have a hard time taking that science and bringing it down to a more understandable view by the average public. The problem with that is we have to talk to the public, so we have to explain to the jury what happened. And if you get up there and technobabble, and that's what they call it, if I get up there and technobabble and try to show my investigative prowess because I know so much, basically what I'm gonna do is I'm gonna lose the core. I'm gonna lose the jury because they're not gonna be interested in what I have to say. So it's really important that digital investigators learn how to speak in common terms. For example, when I testify and I talk about a file system, I use a library example. Books on a shelf are the data files in the storage area, and the Dewey Decimal System is the file allocation table that references or shows the user where to go to find the book. So I use terms such as that. I use analogies that bring people to something that they may associate with so that they can understand what it is I'm trying to get across. Digital forensics can include any aspect of computer science, information science. You could do network analysis, code analysis, reverse engineering of malware. There's a lot of different things that fall into the digital forensics or analysis world. When you talk about physical medium, we're talking about the actual object, the hard drive itself, thumb drives, things that are basically you can hold. If you can hold it, it's probably going to be physical medium. All right. Today, our drives are not spinning. They're now static. They're not moving. They're electrical. So devices today don't give us the same challenges as some of the drives did in the past. Today we have drives that emulate old drive structure because our tools and our computers are designed to work with the older drive structure, the geography of a drive, and be able to find a specific place or point based on basically a geographic reference on the drive. And then we have active or live network. So when we have an active or a live network, we're talking about Dropbox. You're talking about your OneDrives. You're talking about things that you can get to while the computer is on, or once the computer is on, you have access to it. Okay, and it doesn't have to be that computer. You may be able to get to another computer, but it's something you can access. It's a live form, as opposed to what they call dead box forensics. And what dead box forensics is drives that are not or functionally running. Maybe they've been extracted from the computer. There's a bunch of different ways that we have drives that are not in live form, mostly because you seized it and took it out of the computer. Basic process of storing or of storage. The thing you got to remember about digital forensics, there's 4 pillars of forensics. And in the 4 pillars of forensics, probably the most important pillar of that forensics is keeping everything pristine. And we use the word pristine quite a bit. In other words, I need to keep that evidence in the exact same condition it was when I found it. So if I take a drive, I dismount the drive, I seize that drive, in 3 years, that drive should be the exact same state, or should be in the exact same state as that drive was when I took it. And we can do that. We have signature files called hash files that we can make on a drive. An evidentiary hash file allows me to prove that a drive has not been manipulated or changed. But we've got to make sure it stays in that unaltered state, because if it changes in any way, then the defense has a claim or a defense that, hey, they added things onto the computer. They added the evidence that they're finding. So juries, they don't understand the technical detail, and it's very hard, or it's very, very easy to nullify a jury. And that's really what a defense attorney does. If you talk to a defense attorney, you say, are you about proving innocent guilt? If they're really telling you the truth, they'll say no. We're there to get one person on that jury to not understand or not believe the police. And that's really what they're trying to do. They're trying to confuse, or what they call nullify, the jury. A jury nullification is a classic mistake that happens in court, because if you allow jury nullification, either the prosecutor hasn't done their job, or the witness, the expert witness, is not a good expert witness. They learned a lot from OJ. When you have 12 mitochondrial DNA experts get up on the stand, after a while, the jury, one, they don't really understand what a mitochondrial DNA expert is, and after 12 of them, they don't care. So you nullify the jury, and then you go back to what's the last thing said, and the last thing said was, if it doesn't fit, you must acquit. And that's easy. I remember that. And you get a verdict. The analyst must be able to ensure that results of the analysis come from the evidence. If there are mistakes made on that drive, you've got to be able to go in and say, look, the computer was turned on by accident. There were file system dates and changed, but the user area, the user data container, was not changed. You've got to be able to make sure the jury understands that you are able to articulate that evidence came from that drive, because this is one of those fields where no one's ever going to really see the evidence. They're going to see ones and zeros. They take an electron microscope, they're going to look at a drive, it's going to be ones and zeros. If you look at blood or DNA, you can at least see cell walls, you can at least see cells, you can at least see things. But in a computer, on a computer drive, you're not going to see anything but off and on, less colored or colored fragments on a disk. And that's zeros and ones. So it's your interpretation of those zeros and ones that makes something illegal. So you've got to be able to, one, have credibility with the court, and two, you've got to be able to articulate why that segment of drive, or the segment of the drive, contained a image of something that was illegal. All right, so you may have to go for additional training. You may need a more enhanced background to testify for certain things. For example, I testify in several cell phone cases, and I have the qualifications as a cell phone expert for testifying. I understand the CDRs, how call detail records work, how towers work, et cetera, et cetera, et cetera. But I'm not an Apple expert. I will never try to tell someone that I am an Apple file system expert. I am an Android expert, but I'm not an Apple expert. So if you want to know, if you want to put me on a stand for Apple, I'll be fine, because I've been to the training. I'm sorry, on Android. I've been to the training for Android. I have not been to the training for Apple. So I may have to go back to training to learn how to be an Apple expert when I go to court, because I may be dated in my system. I may be dated in my understanding of how the system works, etc. All right, so it's very important I stay qualified and trained. So when we do analysis, we have steps of analysis: acquisition, authentication, imaging of the drive, wiping, and then restoring. So acquisition. Acquisition is normally done in a forensic lab. Very rarely will you see someone try to do a field acquisition, and basically that comes down to time. If you're out on a crime scene and you want to do a terabyte hard drive, remember that you're probably going to be processing that transfer at about 1 point, well, let's see, if you're using USB 3, you'll be processing about 3.1 gigs per minute. So divide that into a terabyte, you're going to be there for 19, 20 hours imaging that drive. And that's just not something you want to do. So you take it back to the lab, you plug it, put it onto your imager, and you walk away. Come back the next day when it's done. Failing to maintain control of custody. We've talked about this. Chain of custody, chain of custody, chain of custody. It's got to be kept in your control, or you need to sign that over to somebody else so that they can say that I took the evidence from Pearson, and then I maintained it, and then I turned it over to Smith, and then Smith turned it over to Jones. I have to show that chain of custody. If that chain of custody is broken, the evidence is probably not going to come into court. So we've got to maintain that chain of custody. If I'm dealing with a Windows system, I'm always going to use some type of physical write or write blocker. And what a write blocker does, it prevents me adding things onto the drive by normal Windows processes. The name is a little disingenuous. When you hear the word physical write blocker, you think, oh, it must be some device that has a physical wall that doesn't allow you to write to that drive, and that's not true. For the computer to talk to the drive, to spin the drive, to get it to give information, it has to talk to the drive. So if you were to truly block the connection between the computer and the device, you wouldn't be able to ask the device for information. Therefore, you wouldn't be able to do your image. So therefore, it's a software write blocker that basically disables the ability, system layer in the OSI, to write to the physical medium. There's other acquisition systems, read-only mount of the file system. So what I'll do is I'll take a CD, thumb drive, some type of medium, plug it into the computer, boot the computer to that medium. That's not going to spin up the evidence drive. That's going to run from that bootable media that I put in there, and then I can access the evidence drive to image it from that bootable media. And that creates a not a physical, but it creates a software block or a read-only environment that prevents that drive from being written to and protects that drive. Authentication of the data. It's evidence. Evidence has to be authenticated. You can't just walk in and say, yep, this is it, and I really don't know where it came from. I'm just going to go ahead and testify that everything on there is true. It doesn't work that way. All right, you have to have the chain of custody done. You have to have unaltered evidence. You have to have a hash value, which is basically the fingerprint of that drive that you collected. You have to have these things that you could take to the court and say, hey, Your Honor, there's no way that this drive was manipulated. The hash values have not been changed since the seizure. The evidence has been maintained by chain of custody, and the investigator can identify and recognize it by serial numbers or other physical attributes. This is that piece of evidence that was found at suspect A's house, and therefore it should be allowed into court. Judge is going to say, okay. You go in there and say, yeah, we didn't do chain of custody, didn't have time, we have no hash because we don't really know how to do that. You come up with start adding goofy stuff in like that, your evidence is not coming into court. You have got to be able to authenticate your evidence. We never work from the original evidence. So one of the unique things, I think we talked about this in another slide set, one of the unique things about digital evidence is I can make a duplicate copy of the evidence. So I can image that drive, create as many copies as I need, and then I can send those off to other labs, or I can work on those image copies. If I what they call burn the copy, in other words, I do something stupid and cause destruction, I go back to the original, burn out, or I image another copy and I go back to work on that copy. The copy is going to be exactly the same as what's in or what was on the evidence drive collected. This is a best practice. It was argued a long time ago. People used to fight about it, but no one fights about it anymore. Everybody's pretty much on the same sheet of music that imaging a drive is an effective manner to create a absolute duplicate copy of the hard drive. There are two types of imaging when we do image the drives. There's a physical drive and there's a logical drive. The difference between a physical drive and a logical drive is the physical drive gets everything from the beginning of the drive, 001, all the way through the end of the drive. So we're going to get all of the partition information, we're going to get all of the system data, we're going to get everything that's on that drive from the very, very beginning to the very, very end of that drive. If I do a logical copy, now I'm only going to get the partition that I choose. So let's say the suspect has a C, D, and E drive on the computer, and I'm really interested in the D drive. So when I image the system, instead of doing a physical, I say, you know what, I'm just going to do the D drive. So I choose that partition. That might be P2 for partition 2. So I choose P2 in my software, and it then reproduces P2, leaves P1, or excuse me, P0 and P1 alone, and only copies P2. So P0, which is my boot drive, and P1, which is another drive on the computer, are not collected. Well, the problem with that is now you've got some arguments. Why didn't you collect it? Are you hiding something? Is there exculpatory information on P0 and P1 that would set my client free? What were your thoughts? Isn't it best practice to do the entire drive? And most investigators are going to fall with unless there's a speed or a time issue. Let's say there's an exigent circumstance where you have to produce, let's say I have a missing child, and we want to get on that drive really quick to see if that child had sent email message or something so that we can track or follow the kid. We're within a 24-hour period and we're considered basically a hot pursuit. I might only image that area that's really important to me, the chat logs or the email, because I'm really focused on a specific thing within that system. Later on, I'm going to go back and I'm going to make an entire image of that drive. But for expediency, at the moment, I might do a logical collection. But I'm always going to come back and do a physical collection of that drive later on. The other type of media that we can collect, something called virtual memory or RAM memory. I can do a RAM dump or a virtual memory dump. And when I do that, what I do is I take the memory that is in the computer that's turned on. It has to be on. And I extract that out from the computer. So then I might find unsaved notes. I might find communications. I might find things that have not been put into the system just yet. So there is an opportunity of grabbing virtual memory. But again, logical, that is going to be your drives that are given letters, or if in a Linux system they're / names. The drive is going to be the actual physical drive that all that sits on. So you could have one drive with many partitions, and then the memory is going to be that which sits inside the computer, and then you collect that memory as it's running to see if there's any information in the memory of a computer before you turn it off. One of the biggest mistakes that analysts makes is they'll grab a drive from a previous case and they'll start putting data on it from a new case. It creates something called cross-migrated evidence or cross-migrated data. And when you have the possibility of cross-migrated data, you may end up having a mixture of two cases being put into one. Now, if you're making image files, the likelihood of you cross-migrating data is small. If you are imaging the drive using, say, a DD copy or a direct copy where you copy everything on the drive to another drive the exact same size, and you make an exact copy of that drive one-to-one, now you have a bootable drive, and you put that on a drive that already has data on it, yes, you're going to have cross-migrated data at that point. So you may have evidence from two cases that have been put together, and you may find the same information from case to case. Your evidence is now corrupt, and you're probably going to lose your evidence going to court. The FBI was a victim of this. They had a system that kind of failed, and what had ended up happening is the same suicide note appeared in 8 different prosecutions, and people went, wait a minute, we've seen the suicide note before, why is it in this case too? And then they found out that the procedure for wiping, the system actually didn't wipe the drive like it was supposed to. It was only formatting the drive, and that's not going to work for you. Once I wipe a drive, I'm going to hash the drive to prove that the drive space has been cleared. I'm going to compare that with a hash that was taken of a wiped drive prior to me putting evidence. I'll compare those two to make sure that I actually have wiped the drive. Restoring the drive. If I'm going to restore the drive, and I really don't like the wording here, restoring, because we're not really restoring the drive. We're loading the image into a computer software package that is going to allow us to do an analysis of the image collected. If I what they call blast out the copy onto another drive, and then I boot that drive, I might do that if I'm looking at maybe a hacker screen because I want to see what the hacker tools were available, maybe a identity thief to see what tools they were actually using on their desktop. But normally I'm just going to bring everything up in my forensic tool. So actually I'm not restoring anything, because restoring gives you the thought that I'm actually putting everything back and recreating the drive. I'm really not. I'm analyzing the imaged copy as it is. I'm not restoring anything. I'm just basically going through the contents of that drive, looking for evidence items. It would be kind of like someone saying, well, I'm going to restore this book when I read it, because I'm reading the words and I'm restoring the words into my brain. You're really not restoring anything. You're analyzing the new data, looking for information. Again, just a little pet peeve there. Forensic analysis. there's several different types of methods to conduct a forensic exam. There are two criteria that really aren't talked too much about in the book, but I'm going to give them to you anyways. There are two criteria that really drives this train, and this is from the real world: time and money. When the prosecutor comes to you and says, hey, we got this case, it's a pictures case, it's all child pornography, I need 1,000 images and that's it, cut it off after 1,000 images because I'm only going to charge this guy 1,000 times, or 1,000 counts because that's all I can charge him under the state statute. At that point, stop. You've now been given your kind of your marching orders from the prosecutor. The prosecutor is the one that's going to run the case. They're going to have to explain why you did what you did. If the world was perfect, you would start with a extensive analysis. You would start with the drive and you would go through the entire drive. But drives are too big now to do that. So now what we need to do is we need to go in and really look at where the user containers are. So when I start my analysis, I may start with the user container, document set, or documents, pictures, videos, all the things that you would find in normal documents and settings. I then would go out and look for containers that the person saved things to, maybe a link to a Dropbox or OneNote, something such as that. And then once I've gone through that information, I may or may not have enough information to make an informed inculpatory, exculpatory decision that there is something on this computer. If there is something on this computer, then I'm probably going to dig in a little bit deeper. But again, it's going to depend on the type of case you have. If you have a child exploitation case and they're distributing child pornography amongst each other, looking at email could be useful, but you want to find a storage drive where all the pictures are stored, because those are going to be the things that actually put the person in jail. The email going back and forth, yeah, that shows collusion with other people. That shows maybe a conspiracy for a group, but it's not going to give me the thing that puts the person in jail for a very long time. So I may have additional investigations that spawn from my initial investigation that then turn into the conspiracy or collusion case, etc. So I'll start out with one thing, which then leads me to other findings, which I'll need new search warrants for, which I'm going to need new prosecutorial review for, so that I can then go out and investigate those other or those added on crimes. Overanalysis is just as bad as underanalysis. If you have a perfect investigator that is going to go through the entire drive and they're not going to miss anything and they're just going to keep going, they may spend 2-3 weeks on a single drive. If you're in a busy department, you're in a busy area, and you've got 15 drives or 15 cell phones or 100 thumb drives coming through your door every week or every 2 weeks, you don't have time to do that extensive analysis. If you're in a small department somewhere and you might get a hard drive once every 6 months, okay, well, you can make that your hobby, and you can go in, you can do an extensive analysis. But the likelihood that you're going to do that is probably going to get cut short by your prosecutor, who's going to run out of money for your case. And then they're going to tell you, we only got X amount of money for the case. This is what we want, the time we're going to pay to the sheriff's department for your time, and this is all I need. And that's really going to be your parameters, your left, right. Or they'll come to you and say, this is time sensitive. We need something today so that we can hold this guy in jail for X period of time. The expert witness. So the forensic analyst, we generate reports, and in the report, you're going to identify the evidence. You're going to articulate in your own words what you saw. You're not expected to be a pediatrician. You're not expected to be a currency expert. You're not expected to be a narcotics expert, but you have to be able to explain why an image, picture, document was interesting to you. You're going to have to articulate that in your documentation. And forensic documentation can be extensive and expansive in a lot of ways. You need to also try to help the prosecutor understand the elements of the crime that had to be established for a crime to be committed. All right, so certain things have to happen within a statute for that crime to be a crime. Missing any one of the sub-elements of the statute may eliminate that piece of evidence because it just doesn't hold up anymore. Summary of the evidence that's created. So you're normally going to produce a review or a file listing. You're normally going to produce a picture listing. You're normally going to produce your key log, what you searched for, the time that you spent on it, things such as that. And then you're probably going to have to go in and testify to all of this stuff that you've just done, and you're going to have to testify to your qualifications, why you are going to be able to tell the court what this person did or didn't do. All right. And a lot of times the judge is going to ask your opinion. The judge may lean over and say, well, what do you think? And that's a very dangerous question, and judges love doing that, but they also know that's a very dangerous question because technically we don't have thoughts as forensic analysts. We're there as an unbiased fact gatherer. We have no opinion beyond fact. So if I can't produce something in fact, I don't have an opinion about it. But again, the judges love leaning over and saying, hey, what do you think this, and this? And, you know, if you try to play kind of hard to get, like, oh, I can't give you an answer, then you're going to get the judge upset, which never goes well for you later on. So a lot of times you end up giving a little bit of an opinion, but stay away from opinions as much as possible. Remember, you're a fact finder. You are a fact checker. That's what you do. You live in the world of fact, empirical evidence that you can prove or disprove. Inculpatory and exculpatory. You're also going to have to understand how to, or you're going to have to be able to articulate how you found something on a drive. So if I say I found something on the C drive in this subfolder, well, the prosecution may say, don't say that because there is no C drive. And they're absolutely correct. Once you empower the computer, the C drive goes away. Now you have partitions, and when the computer boots up, the partition is read by the computer system. It's given a drive letter. So on another computer, that drive letter could be something different. So a lot of times they want you to stick to the actual partitions. So on physical disk 1, partition 1, in a subdirectory X, we found images of, you know, potential bad guy stuff. As we move into newer storage mechanisms, as we have new operating systems come out, the naming structures change, the file systems change a little bit, and the growth of those storage capacities get so large that we may end up just having to say we don't have the ability to do that entire drive. If there's a petabyte storage container, you may not have the time or the equipment to do an actual extraction of everything that's on that drive. So one of the things that's really complicating our new world is the size of the storage containers. They simply are getting so big that it's almost humanly impossible to go through. And that's why there's a greater reliance on AI, which is super dangerous. I can go on for a while. I talked to Interpol about the problems of AI finding evidence for you. There are so many issues that go along with that. Or you're restricted to a container that you know where evidence might be found. So there are lots of issues that are coming out with mobile devices, larger mobile device storage containers, online storage containers, you know, hard drives with huge containers. I have an 8 terabyte hard drive on this computer. 8 terabytes is a huge storage container, and I have 6 terabytes filled on this drive. All cat pictures and cat videos. No, just kidding. But No, I have 6 terabytes of data. You would have to go through 6 terabytes of data. Good luck. Without some type of device or some way of getting through it, some automated process, you're not going to do well when it comes to that massive drive. All right, so volatile storage containers. If I unplug the computer, it goes away. Data is lost when the computer is turned off. Things in the processor go, the cache goes, and the RAM goes. The RAM is a very important piece. The RAM holds active data that's going on the system at the time that you seize that computer. You may have Word files, Notepad files, PowerPoints, email messages, WhatsApp, Snapchat, all kinds of other things that might be in RAM that haven't been purged yet that you can get by dumping the cache or dumping the RAM out. So one of the newer realms of forensics in the last 5-6 years has been RAM cache analysis. And RAM is becoming very productive in the evidence. So is the registry. The registry is something that's been around forever, but no one really got into the registry until recently, the last probably 7-8 years. And now the registry is just a wealth of great information. Non-volatile storage, thumb drives, hard drives, anything that holds power or holds storage once the power is taken off. CD drives, removable storage containers, USB drives, all that kind of stuff. So when you have a non-volatile storage container, you take the power off, you disconnect it from the computer, the data is still there. We can now go on with a forensic computer and look directly at that drive or medium and pull the data back. File systems that are very common in the forensic world or forensic exploitation. The file allocation table, this is your oldest of your tables. The file allocation table allows you to have a system area and a data area, and all of your records are basically in the system area, and all of your data is in the data area. File allocation table fragments more than any other one of the operating systems. So it was a good system for us because there was lots of leftover data that wasn't cleaned up correctly. The new technology file system came out. This is Microsoft's NT systems. You now see NTFS on most computers when you look at them. And this now moved the storage of the system or the file system into the actual drive itself. So the MFT table basically became a database so it could shrink and grow, and it became much more efficient than the old FAT system. It made it much more difficult to find lost or fragmented information on the drive because it was constantly fragmenting itself or defragmenting itself as it saved data to the drive. Dynamic disks and EFS, these are relatively new systems. These allow for very efficient file systems. The encrypted file system, the EFS, which is on most laptops, they come natively with EFS, is a chip base inside the BIOS that works with the operating system. So it validates that that system can be booted and used by any of the applications that you're trying to run, Windows or whatever. So if I get on your computer and I have a forensic tool and I try to boot your computer and I don't have an EFS method in my boot device, I'm not going to be able to get to your drive, and it's going to prevent me from getting onto your drive. So we talked about defragmenting a little bit. Fragmenting happens when disk space is removed, or applications and things are removed from the disk space, and basically holes are created. So imagine a bunch of Legos, and you have them lined up, one Lego right after another, and you have different size Legos. So you might have the 6-piece Lego, and then you have the 4-piece Lego, and then the 2-piece Lego, and you kind of lay those in, and you think that's pretty cool. And later on, you come back, you say, well, you know what? I could take out those two 2-piece Legos and put a 4-piece in there. So you take two 2-pieces out, and you put a 4-piece in there, and you say, you know, I can make a, maybe I don't want that 4-piece, so you pull that 4-piece out, and you say, you know, I'm just going to leave that off. Well, what I've done is I've created a hole. Okay, so now I have, it's a contiguous file system. I have a blank spot, and I have more files. Or let's say that you have a bunch of different colored Legos, and you lay your Legos in one right after another, and you have red, blue, yellow, green. You're just picking them up and you're putting them on the drive. And that's kind of what happens to files after a while. It looks for a space to put the drive, so you might have a bunch of different files, but you may have files that are the same color, but they're located in different places in the line. Well, what defragmenting does is it allows you to take all the colors and put them into their color right, or their right color alignment. So I have all the red, then I have all the blue, then I have all the yellow and all the green. And that defragments, and it makes it a lot easier for the computer to find all the red pieces in one line. It allows me to find all the yellow pieces in one line, where before I had to find one red piece here, and then oh, there's another red piece, and there's another red piece, and it created an inefficiency in the file system. So as files were broken up and stored wherever there was room to store them, well, it created an inefficiency. The computer knew where every bit of your, or all the file segments were and all the file system parts were, but it was all spread out and split up. So defragmenting allows me to realign those, creating efficient file system, a much more efficient system. And this is really used in the FAT systems. Again, NTFS does not require defragmenting because it does what's called on-the-fly defragmentation. There's a time where there was a lot of data you could find in slack space. So let's say that you deleted the file, the yellow bricks, but you didn't delete all the yellow bricks. You just deleted some of the yellow bricks because it didn't, the system didn't work right, or for some reason it held on to a couple, or maybe it didn't need to delete it, just need to get rid of that first brick, which was the identifier for all the other bricks, and then all the other bricks just became unassociated. So now what I can do is I can go to all those other little yellow bricks that are in that line, and I can see maybe what was in that brick. So I might be able to look at that line of bricks and say, okay, there's the yellow bricks, and I'm going to plop those out, and now I have a file. I have at least part of a file that tells me enough about what that person was doing that, you know, I can tell it was a picture, a video, or something else of interest. Okay. You don't get that as much now with the new systems. The new systems are much more resilient, much more efficient, and finding slack space documents, they're still there, but they're not there in the quantity or the wealth that they used to be and what they used to produce. Commercial forensic packages. So there's some challenges with forensic packages. First of all, they're a lot of times very complicated. You have to go to training for them. You basically sit in front of a screen and you're watching keyword indexes and you're typing in keywords, and burnout, like it says here, burnout and fatigue kick in pretty quickly. So now you have a complicated system with not the greatest of graphical user interfaces that is giving you redundant tasks to do over and over again, and the human body just goes, enough. And you burn out, you know, you get fatigued with that system. And this comes again from doing extended analysis, searching, changing keywords. You know, there are some diligent people. I've had some friends in the past where they would sit at a computer for 12 hours, they would never move, and they would run scripts. I had other friends that after 15 minutes, they were at the coffee machine, They were walking around outside. They just couldn't handle sitting in front of the computer for that extended period of time. So you're going to know, or you're going to find there are people that are drawn to computer forensics, and you're definitely going to identify those people that are not going to be good in the computer forensic world. Any good package is going to have basic functions like importing data, hashing, wiping, imaging, and search capabilities. You're also going to be looking at automated tools, so it's going to find the email, it's going to find messages, it's going to identify the file system. It's going to do a lot of other automated basic tools for you. That's going to be a good package. You can find them from open source all the way through the more expensive packages that run $13,000 for the program, and then $3,000 every year for the license fee. So you can spend a lot of money, and the functionality of that system over the free system, it's kind of depends what you're doing. If you're doing petabytes of storage and you're doing Bank of America's all the time, absolutely get your $13,000 system. If you're doing local computers or normal computers that are caught in a typical crime scene, then the open source free software is probably going to work for you. In this course, you're going to get to use a very cool tool. It's called FTK Imager, and it's not open source. It's a communityware, so it's free, and you can use that to do imaging and some light searching, things such as that. And you're actually going to do that when you run your case. A lot of times computers can't interpret symbols, but they can match patterns. So computers AI, especially forensic AI, is really good, but they have their limitations. If you don't have an interpretive package on your forensic computer, it's not going to be able to identify Arabic from English. It's not going to be able to identify things that you think it should. Normally, a base forensic package comes as a base forensic package, then you have to buy all the additional add-ons. So when you do the $13,000 system, you then have to buy your interpretation pack. You then have to buy maybe your mail interpreter pack. You have to buy all these other packs that help you with your work. Speed's a big deal. A lot of forensic packages, that's what they sell their soul on, is the speed of being able to process the data. That's their core, is how quickly they can go through data. And I would argue there are times where speed is akin to missing things, because if you're processing a gigabyte container faster than my process, I need to know what it is that you're running, because we still have the same amount of data. So I need to know how your algorithm interprets or goes through the data faster than the algorithm that I'm using. Oh, forgot to mention, there is no algorithm authority, and every company has their own proprietary algorithm or methodology for going through. This is one of the things about forensics, computer forensics, that just is very disheartening, because there is no body or group or board of governance that says, send us your algorithms so we can validate your algorithms. There's an implied trust that the company sold this algorithm, so therefore it works. That may be fine if you're playing games, but in my opinion, when you're putting people in jail, there needs to be someone checking the checkers. And you need to have a power search. Okay, a power search is something you can write. So I need to have the ability to write my own regular expression searches or regex expressions that allow me to create a complex search pattern that goes out and looks for specific data. User interface. Fatigue is a primary concern. When you're looking at a screen that is blue and gray, and the blue and gray is mixed with gray letters, and it's just this drab, people just get killed by the fatigue of the fatigue of the system. There's also large backlogs of data that are pending. So there are departments that have great tools, great computers, but they have a huge backlog of cases that they try to work through. So they're tasking their analysts to try and catch that backload up. By doing that, though, the problem is they really wear out their investigators. You should also have a forensic package that comes with shortcut keys and the ability to run through data relatively quickly without having to click through 100 different screens or right click here and left click here to get into screens. Packages need to be very simple, and they need to be able to process quickly. So I can put my command in or my search term in very quickly so it can get out and do its job. And then they basically all have the same format. What starts off on the left screen goes to the top right screen, it goes to the bottom right screen. They basically all have the clock form interface. So once you've learned one package, you really can pretty much sit in front of any forensic package. They all look basically the same. And that can be tough sometimes because people get confused between systems, especially when they change systems up on people a lot, or you have multiple applications you have to run for different products. So that can be very detrimental to your forensic analyst. Once you have your report, you should have a central report writing and auditing system. It should have the ability to log all of your searches. It should be able to print out everything. You should not have to sit and write down everything that you do. The forensic package really needs to have the ability to include those logs and your audit trail inside of the witness report. You need to have a good, extensive report writing feature. And there are, even in the more expensive packages, the report writing is something that has always been a complaint of users and forensic analysts, because most of the time those reporting tools are very poor. You also have to have validation support. It has to have the ability to validate the information that's inside the system. You need to be able to do hash tracking. You need to be able to hash everything that's in the computer. You need to be able to keep up with the changes. So if you've got a vendor that is constantly putting out new stuff, that may cause a problem in your standardization. You may have to go back to training too much for a software package. And I've known companies that have have gone out of business because their efforts to provide the latest and greatest caused upgrade fatigue inside the departments and inside the investigators, because they were constantly having to learn new things, and their standard practices suffered because they just could not keep that. You also got to remember, when you have standard practices, you're going to have other people looking at that, and if you have external experts or if you have someone else that comes in to testify in your case, they're going to have to look at your procedure and say, yeah, that makes sense. What they did was right. If you're not doing it right and someone comes in and says, man, I have no idea why they did what they did, it doesn't make any sense, the standard practice is X and they do Y, well, you're going to be on the stand for a lot longer trying to explain why it is you did what you did with the tool you have. Okay, and then packages can just be extremely cost prohibitive, like we said. That's why there's a lot of training now in the open source. That's why there's a lot of movement in the open source world where people are putting together packages for law enforcement. All right, so like I said when we started out, this is not going to be a extensive certificate-bearing digital forensics course. It's basically hitting the wave tops again. Read your book. Make sure you look at the sidebars. Get out on the web and look up forensic tools, forensic packages, and just see how many different digital forensic tools there are out there. Then add the cell phone tools. You'll see there's a whole another group of tools, and then start working down to email tools. And by the time you get done, you're going to have this massive list of software that you could have in your department. And if you do that to an investigator, you're basically killing that investigator, because one, they're not going to be able to go to training for all of it. They're not going to be certified in it. They're not even going to be proficient in most of the tools. So you're not, by providing more and more tools doesn't always help the investigator. Making the tools they have as powerful as possible and as easy to use as possible really is something that is useful to the forensic investigator. So with that, I will let you go, and I will see you in the next slide set.